Okay, we will be multiplying powers with the same base. Now, what's a power? Power is made up of a base and an exponent. You've seen them all over the place. 3 to the 4th is a power. The base is 3 and the exponent is 4. But the whole thing is called a power. Okay? You may not have heard of it referred to as that way before, but that's what it is. Alright, so we've got this power, 3 to the 2nd. And if you write it out, that means that you multiply it by itself 2 times. 3 times 3, 9. Now 3 to the 3rd means that you multiply it by itself 3 times. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 3 to the 4th means that you multiply it by itself 4 times. 3 times 3 times 3 times 3, and you get 81. So if we have something like this, what will the exponent be? But we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, and we put a 9 here. So that's 3 to the 9th. So it's just the exponent tells you the number of times that you multiply the number by itself. So now we've got 3 to the 2nd times 3 to the 3rd. We're multiplying a power times a power. The bases have to be the same. Okay? Notice that we're multiplying a base of 3 times a base of 3. A base of 2 times a base of 2. A base of 5 times a base of 5. You cannot go 3 to the 3rd times 2 to the 2nd and combine them. You can do the multiplication. You just have to go 3 to the 3rd is 27. 2 to the 2nd is 4. And multiply it and get out 108. But you cannot go 3 times 2 is 6 and combine them that way, okay? Can't do that. So you have to multiply powers that have the same base. 3 and 3 are the same, so we're allowed to do it. 3 squared is 3 times 3. 3 to the 3rd is 3 times 3 times 3. So if we count these, we've got 1, 2, 3, 4, 5. So that means this will be a 5. Then we've got 2 to the 4th times 2 to the 4th. The bases are the same, 2 and 2. So we go 2 times 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 2. And we get 2 to the, when we add all these up, we get 8 of them. So we could do that. We could write them all out and then count them. But there's got to be a simpler way. Because when we do 5 to the 45th times 5 to the 50th, we certainly don't want to write out 45 5s and 55s. So we have to find an easier way to do it. So we look up here and we see 3 to the 2nd times 3 to the 3rd is equal to 3 to the 5th. And 2 to the 4th times 2 to the 4th is equal to 2 to the 8th. Have you noticed the shortcut? We go 3, where'd my cursor go? There we go. 3 to the 2nd times 3 to the 3rd. 2 plus 3 gives me 5. 4 plus 4 gives me 8. Therefore, 45 plus 50 will give me 5 to the 95th. So when you're multiplying powers with the same base, all you have to do is add the exponents. And there it is in writing. When you're multiplying powers with the same base, you keep the base and add the exponents. So let's look at a few here. We've got x to the 5th times x to the 6th. That gives us x to the 11th. We have b to the 9th times b to the 5th. That gives us b to the 14th. We have 2 to the 6th times 3 to the 2nd, and that gives us nothing because we're not allowed to do that. The bases are different, so you couldn't do it. That was a tricky. Alright, now you do it. We got 3 of them over here. Pause the video, try them, and then come back to me. Okay, we've got 8, same base, so we write the base down, and 3 and 6 make 9. We have the same base as 0.5, so we've got 0.5. Add the exponents, and we get 19. We've got 9 to the negative 3 and 9 to the 6, so we add Negative 3 plus 6 gives us positive 3. Did you get all three of those? Alright, now multiplying powers in algebraic expressions. An algebraic expression can include numbers as well. So the key thing to remember here is that you're going to be multiplying numbers times numbers and powers times powers. Okay? So we go 4 times 3 and we get 12. We go z to the 5th times z to the 3rd. 5 plus 3 gives me 8. Okay? Alright, you do the one over here. Pause the video, try this one, and then come back to me. Alright, you should have gone 2 times 3 is 6. And y to the 8th times y to the 5th. 8 plus 5 is 13. Over here we've got 2 times 5 is 10. A to the 6th times a to the 9th. 6 plus negative 9 gives us negative 3. So that gives us a to the negative 3. Now, something that's of note here that you're going to have to get used to is that whenever you're writing powers, for them to be in simplest form, it has to be all positive exponents. Okay, this is a negative exponent. This is 10a to the negative 3rd over 1. To make it positive, whenever you change a power from one side of this divisor line to the other side, it changes the sign of the exponent. So if I move this power down to the bottom, that negative 3 will become a positive 3. So this will be 10, and I move the a to the 3rd down to the bottom, and it's positive. Okay? We'll do more of that. Your turn. Try this one and then come back to me. So we got 6 times 10 is 60. T to the negative 10 times t to the negative 4. 4 plus negative 10 gives us t to the negative 6. Now what you should have done is you should have taken this t to the negative 6 and moved it to the bottom here. That would have given us 60 over t to the 6th. Okay? I hope you got that. So let's try these. Remember though that you have to have the same, when you're combining powers, they have to have the same base. So let's see what we've got here. We go number times number times number. 6 times 7 is 42, times 2 is 84. C to the 6, negative 6 times c to the 8th gives us c to the 2nd, because 8 minus 6 is 2. And then there is no other power with the b5, so this will just be b to the 5th. Okay? Alright, try this one and then come back to me, okay? Alright, we've got d to the 3rd. This is a 1, so we go 1 times 2 times 4 gives us 8. d3 times d to the negative 5th times d to the 10th. The powers are all the same, so we keep, the bases are all the same, so we keep the base and we add the exponents. 3 plus negative 5 gives us negative 2, plus 10 gives us positive 8. Okay? Alright, now let's try this one. There are no numbers this time, so we multiply powers that are alike. So we got a to the 2nd times a to the negative 4. That gives us a. 2 plus negative 4 gives us negative 2. B to the 3rd times b to the 5th gives us b to the 3 plus 5, which is 8. C to the 9th times c to the 2nd gives us c to the 9 plus 2, which is 11. And so what we're going to do now is we're going to take this a to the 2nd negative and move it to the bottom so that it'll be positive. So this will be b to the 8th, c to the 11th, over a to the 2nd. Alright, you try this one and then, so pause the video. When you're finished, come back and let's see what you did. Alright, we go j to the 2nd times j, and there is no j over here. So j to the 2nd times j. The exponent when there is no exponent is a 1. So we go j to the second times j to the first gives us j to the third. K times K3 gives us K4 times K8 gives us K12. And then we've got the m is left. So m to the third. I hope that you got that. Now, in the last lesson, we multiplied numbers in scientific notation, but only with a number, not with, we went 3 times 3 times 6 times 10 to the third. So we introduced you to multiplying numbers in scientific notation, but now we're going to have both the numbers in scientific notation, not just one of them. Now the key to this is you multiply the number times the number and the power times the power. Okay? So we go 2 times 6 and we get 12 times 10 to the, remember you keep the base whenever you're multiplying powers. So 10 and 10, we keep the base and we add the exponents. 6 and 9 make 15. Now the 12 is not in scientific notation because it's not between 1 and 10. So we move the decimal one place to the left. We make that a smaller number, 1.2. We changed it by one decimal place and we made it smaller. So we'll make this exponent one bigger. So that makes that 16. All right, try this one and then come back to me, okay? So we've got 3.5 times 3 gives us 10.5 times 10 to the 5 and negative 6 make negative 1. So now we've got to move this one place to the left. So it'll be in scientific notation. So we move the decimal place one place to the left in order to get this to be 1.05. So that means that we made this number smaller by 1. So that means we're going to make this number larger by 1. So one number larger than negative 1 is 0. So this will be times 10 to the 0. All right, try these two. Pause the video, try them, and then come back to me. Right, we've got 9. We just multiply the numbers times the numbers, and you've got 10 to the negative 9. Over here, there is no number to multiply this by, so you just leave it as 5 times, and the powers are 10, and 5 and negative 2 make 3. No problem whatsoever, right? Now, let's make these all positive exponents. Everything needs to be a positive exponent. So this is a to the negative 3 over 1, so we move it to the bottom, and it becomes 1 over a to the 3. All right? Now this one's negative in the bottom. And what I told you was that when you move a power across the divisor line, the exponent changes signs. So that means if we move this to the top, it's going to become a positive a to the third. Okay? Now look at this one. The a to the second is going to need to go to the bottom. The b to the third can stay, and the c to the negative 7 is going to go to the bottom. So that means we've got b to the third on top, a to the second on bottom, c to the 7th on bottom. Now let's take care of the bottom part. D to the negative 1, we've got to move that to the top, so that'll be D to the first. E to the negative 8, we move it to the top, and C to and F. F is positive, so we leave it where it is. Well, the exponent is positive. We don't know if F is positive or not, but F to the first is positive, and we leave it like that. So that's our answer. Now, for your thinking pleasure, if I've got 3 to the x times 3 to the x, how would it look if I combine those powers? I'm multiplying those powers. What do you do when you're multiplying powers? you keep the base and add the exponent. Did you think that through? So you keep the base and you add the exponents. So that would be 3 to the 2x. You got to remember, do the thing that you're learning to do, even when it looks a little weird. Okay. When you're multiplying powers, you keep the base and you add the exponent.